Hello, I am Dr. Sharmani Mukherjee. Welcome to my YouTube channel, Let's Do Maths. Today we are going to discuss about closed sets in a metric space. One of the definition can be considered as a subset F of a metric space XD is said to be a closed set if its complement AC is open in X. It is one of the approach. To define closed set in another way, let us first define limit points. Now, what is a limit points? You already know in real analysis. It is, suppose A is a subset of set of real numbers. A point xi in R is said to be a limit point if every neighborhood of xi contains a point of A other than xi. You know that. Now, instead of every neighborhood of xi, we just consider every open ball centered at xi for a metric space. So, let us write the formal definition of a limit point. So, just write a point xi of capital X where xd is a metric space is said to be a limit point of a subset capital F of capital X if every open ball centered at xi contains a point of capital F other than xi. For example, you may consider any example used for real analysis as R is a metric space with respect to usual metric. So you may consider this type of examples. Let us choose an example. Easiest example. Let suppose capital F equal to close interval 0, 1 and obviously it is subset of R. Here the metric D is usual metric usual metric on R. Then you know that every point of capital F is a limit point of capital F. You know that. Another example, example 2, we consider F equal to 1/2, 1/3 and so on. This is an infinite set and you know that the only limit point of F is 0 which is not a member of F. So 0 only limit point of capital F, and we know that, note that 0 not in capital F. So, considering these two examples, we can realize that a limit point may or may not belong to the set. Now, the set of all limit points of a set F subset of capital S is called a derived set. And it is denoted by a dashed. And from our discussion, you know that F dash may be a subset subset of capital F or not a subset of capital F? Now, if F dash is a subset of capital F, then we say that F is a closed set. Closed set. Okay? In terms of limit point, we can define closed set or we can define closed set via open set. Now, what is the relation between these two definitions? Obviously, they should coincide. So, if we start with this, we can prove that a subset capital F for which its derived set is a subset of F, then F is closed. On the other hand, if we consider this is the definition of a closed set, then we can prove this as a theorem. Later, we can discuss about this part. Now, let us consider another example from R2. Consider the set capital F consists of all those points of R2, xy suppose, for which xy equal to 0. So, what is the graph of F? xy equal to 0, that means either x equal to 0 or y equal to 0. So, capital F actually these two axes are represented by capital X. These two are the members of capital F. So, now find any point here whose coordinate should be x0, and if you consider any in R2, it should be a circular disk, and you can see that many points here belongs to this open circular disk other than the point x0 itself. Similar for y-axis, if you consider here any point 0, y and you consider a circular disk centered at 0y, you can see that these points, all these points belongs to the circular disk other than this center. So, every point on the y-axis and every point on the x-axis are limit point of capital F. So, the derived set F dash equal to capital F itself, and therefore capital F is a closed set. Okay? Bye for today. If you have any query, please write it in the comment section. Please like, share and subscribe my YouTube channel. Thank you.